you buy organic food, there's a good chance you do it because you believe it means fewer chemicals, fewer pesticides, and cleaner soil. And you're mostly right. But here's what a 2024 study published in one of the world's top environmental science journals actually found when researchers went out and tested soil from 201 farms across 10 European countries. Pesticide residues showed up in 97% of all samples. That includes organic farms. In fact, residues were detected in 95% of organic fields tested. Now, before you throw out your organic groceries, this finding is more complicated than it sounds. And the explanation tells us something important, not just about organic farming, but about how long chemicals stay in the environment and what it means for soil health globally. Firstly, let's make sure that we're starting from the same place. Organic farming, by definition, prohibits the use of synthetic pesticides. When a farm gets certified organic in Europe, it has to go through a transition period of at least 2 to 3 years, sometimes even longer, during which it stops using prohibited chemicals before it can sell products as organic. The idea is to ensure that there are no synthetic pesticides in the soil. That is the implicit promise that most consumers believe they are actually paying for. And by most measures, organic farms do deliver on that. Organic soils do have far lower pesticide loads than conventional ones, and we'll get into those numbers in a moment. Now, the Knuth study that we're looking at raised a harder question. Even when farmers follow the rules completely, even when they haven't sprayed a single prohibited chemical, is the soil actually clean? The answer, it turns out, is not entirely. And the reasons why are genuinely important. The study was led by Dennis Knuth and a team of researchers from universities across Europe, including Wageningen University in the Netherlands, which is one of the world's top agricultural research institutions. Now, here's what they did. During the 2021 growing season, they collected soil samples from 201 agricultural fields, roughly half organic, half conventional, spread across 10 European countries. These include Switzerland, Czech Republic, Denmark, Spain, France, Croatia, Italy, the Netherlands, Slovenia, and Portugal. They then tested those samples for 192 different synthetic pesticide residues. That's a very broad screen. Most previous studies tested far fewer compounds. Here are the headline numbers. Pesticide residues were found in 97% of samples, of all the samples. 88% of samples contained mixtures of at least 2 different substances. Conventional fields had mixtures of up to 21 different pesticide residues in a single sample. Organic fields had mixtures of up to 12 different residues. So yes, conventional fields are significantly more contaminated. However, on average, organic soils had pesticide loads about 8 times lower than conventional soils. That difference is real and it matters. But the finding that 95% of organic fields still contain detectable residues is what makes this study worth talking about. So how does a farm that hasn't used synthetic pesticides end up with synthetic pesticides in its soil? The research points to 3 explanations, and they are not mutually exclusive. Explanation number 1 is based on legacy contamination. The soil has memory. Most of the farms in this study had been certified organic for at least 5 years. But here's the thing. Many of the residues detected were from chemicals that are no longer even approved in the EU. Chemicals that were banned years, sometimes decades ago. A companion study from Switzerland found something striking. Even after 20 years of organic management, researchers still detected between 3 and 16 different pesticide residues in the soil. Specific herbicides, linuron, atrazine, and certain fungicides were still showing up decades after the last application. This is because the official degradation timelines for many pesticides are wrong. They are calculated under laboratory conditions that don't reflect real soil environments. A French national soil monitoring study found that AMPA, the main breakdown product of glyphosate, has a theoretical soil persistence of 1,000 days. A triazole fungicide called epoxiconazole was estimated at nearly 3,000 days. That's over 8 years. So in practice, many chemicals persist far longer than regulators assume. So a farm that converted to organic in 2010 may still be carrying the chemical legacy of what was applied in the 1990s. Explanation number 2 is based on pesticide drift. Farming doesn't happen in isolation. When a conventional farm sprays pesticides, those chemicals don't stay neatly on that field. Wind carries particles, rain washes residues into shared waterways, and dust moves across field boundaries. If your certified organic farm sits next to a conventional neighbor, you are receiving a low but continuous dose of whatever they're spraying, whether you want it or not. The Knuth study found that spray drift and atmospheric transport are likely responsible for many of the lower concentration detections on organic farms. And in Europe, where organic and conventional farms are often interspersed across the same landscapes, that is not a marginal problem. Explanation number 3 is based on active but unreported use. This is unfortunately the uncomfortable one, and the researchers were very careful about it. The correspondence paper responding to the Knuth study highlights 3 farms, 1 in Switzerland and 2 in Spain, where pesticide concentrations were so high that legacy or drift contamination couldn't plausibly explain them. Concentrations above the 84th and 92nd percentile of conventional farms. The researchers concluded these concentrations most likely came from recent intentional applications, meaning someone applied a prohibited pesticide on a certified organic farm. The study can't prove this for any individual farm, but the data is difficult to explain otherwise, and it raises a real question about the integrity of organic certified systems in some regions. Now, here's why this matters beyond the headline. The same Swiss study that tracked pesticide persistence also measured what those residues were doing in the soil itself, and the findings are concerning. Fields with higher pesticide loads, including some organic fields, showed lower microbial biomass and significantly reduced populations of avascular mycorrhiza fungi. These are fungi that form symbiotic relationships with plant roots, helping crops absorb water and nutrients more efficiently. They are fundamental indicators of soil health. In other words, the pesticide legacy isn't just a chemical problem, it's an ecological one. Soils that look like they've recovered because they're managed organically, because yields are fine, may still be functionally compromised underground in ways that don't show up until you look at the microbiology. And here's the regulatory gap that this exposes. Almost all pesticide risk assessment focuses on food residues. What ends up on the fruit or vegetable you eat? Very little monitoring happens at the soil level. The Knuth study itself was noted as providing data that essentially didn't exist before at this scale across Europe. So, what should we take of all this? First, and I want to be clear about this research doesn't mean organic farming is a fraud. The numbers show consistently that organic soils carry a fraction of the pesticide load that conventional soils do. If reducing synthetic pesticide exposure is your goal, organic farming delivers that. But this research does challenge the idea that organic certification is the same thing as chemical-free soil. It isn't. And it probably can't be, given how long some of these compounds persist and how freely they move across landscapes. Buying organic is still a reasonable choice. But what this research asks us to do is think more carefully about what organic certification actually guarantees and what it can't. It can guarantee that a farmer isn't intentionally applying prohibited chemicals. It cannot guarantee that the soil is free of a decades-long chemical history, or that what drifts in from the next field stays out. The real takeaway from this paper is simpler than the debate about organic versus conventional. Our soils are carrying a chemical load that we don't fully understand, that persists far longer than we model, and that we barely monitor. And that matters for soil health, for biodiversity, and ultimately for what we grow in that soil. The researchers are calling for better soil monitoring at a larger scale. That seems like a minimum starting point. If you found this useful, subscribe. There's a new video out every week. And drop a comment. Does this change how you think about organic food? I'm genuinely curious. Have an awesome day.